Hey everyone, welcome back to The Explainer. Today we're tearing into a massive topic in polymer tech, literally the plastics industry's second biggest product. We're talking Black Masterbatch. Now, if you're in manufacturing, engineering, or product design, you already know black plastics are absolutely everywhere. So we're skipping the basic stuff today. Instead, we're going to dive straight into the deep formulation science that actually makes this material tick. Okay, let's dive right into this by busting what I like to call this simple formula myth. A lot of folks out there think making black masterbatch is, incredibly easy. Just toss some carbon black powder into a polymer carrier, maybe splash in a processing additive, and boom, you're done, right? Well, absolutely wrong. The reality, creating high-quality black masterbatch is a really precise science. It relies heavily on dispersion dynamics, microscopic undertones, and exact particle sizing. If you just guess on your carbon selection, your final plastic is going to end up looking gray, maybe brown, or just completely dull. So here's our roadmap for today. We'll start with the myth, then cover carbon black and Jetness, carrier selection, the dispersion secret, troubleshooting defects, and finally wrap it up with the golden rule. All right, let's kick things off with section 1, the black masterbatch myth. So a black masterbatch is actually a highly concentrated mixture, and it's got surprisingly broad formulation ranges. Look at this breakdown. The carrier polymer makes up anywhere from 45 to 78% of the mix. The carbon black pigment usually sits between 20 to 50%, and your processing additives, they're just a tiny slice, right around 1 to 5%. Now, you might be wondering, why such massive ranges? Well, it's because the recipe depends entirely on what you're actually trying to build. Are you aiming for heavy UV protection for, say, outdoor patio furniture? Or maybe you're trying to achieve electrical conductivity for a super specialized component. Or, hey, maybe you just want the absolute most cost-effective coloring possible. Your specific end goal dictates exactly where you're going to fall within those proportional ranges. Moving right along to section 2, carbon black and Jetness. Now, carbon black is obviously the primary source of your black shade, and it gives you high tinting strength, heat resistance, and UV protection. But what's really interesting here is that simply dumping more black powder into your mix does not automatically make your product better, or even blacker. Actually, your final performance is dictated by 4 vital parameters. We're talking particle size, structure, surface area, and undertone. You literally have to balance all 4 of these to hit your target. And that brings us to a huge piece of industry jargon you absolutely need to have in your back pocket: Jetness. So Jetness is a measure of how deep, rich, and premium the black color appears. Think about it like this. Picture the sleek, glossy black paint on a luxury sports car, and compare that to, well, a faded black plastic trash can sitting on the curb. I mean, they're both technically black, right? But that sports car has incredibly high Jetness. And in today's market, customers don't just want dark products. No, they demand that deep, premium Jetness. So how exactly do we achieve that premium look? Well, it largely comes down to particle size, which actually presents this classic engineer's dilemma. See, if you use a smaller particle size, like those high jet furnace black grades, you get incredible deep Jetness and superior UV resistance. But here's the catch. Those tiny particles absolutely love to clump together. It makes them incredibly stubborn and difficult to mix. On the flip side, larger particle sizes are way easier to disperse smoothly during the manufacturing process. But, you guessed it, you sacrifice that premium Jetness. It's this constant, ongoing trade-off between getting the ultimate visual quality and keeping the manufacturing process running smoothly. Let's look at another one of those vital parameters: undertone. Because believe it or not all carbon black is just black. For instance, a bluish undertone gives off a highly premium appearance, which is exactly why it's the gold standard for automotive applications. Meanwhile, a brownish undertone is perfectly fine for functional, hidden things like underground pipes, where the exact tint really doesn't matter. And neutral? That's your general purpose standard. So here is a super practical R&D tip for you. Never ever just compare darkness when you're trying to match a customer sample. You absolutely must identify and match these specific undertones. If you don't, your final product is always going to look just a little bit off to the human eye. Okay, let's shift gears to section 3, choosing the right carrier. So the carrier's whole job is to act as a vehicle to deliver that carbon black evenly into the final product. And the golden rule here is simply compatibility. If your end product is made of polypropylene, well, your masterbatch carrier must also be PP. Are you making thin plastic films? You're going to need LDPE or LLDPE. Manufacturing heavy-duty pipes? You don't need high-density polyethylene. If you mismatch the carrier to your final product resin, honestly, it's a disaster. You're going to experience severe surface defects, zero shade consistency, and outright mechanical failures. Which leads us nicely into Section 4, Dispersion, the real secret to success here. Listen, if your carbon black doesn't disperse evenly throughout your carrier polymer, your entire batch is ruined. Poor dispersion is literally the ultimate enemy in this industry. It leads directly to these unmixed black dots, really nasty surface streaks all across your plastic parts, and completely compromised structural integrity. When the science fails here, the production line just grinds to a halt, and honestly, that's just money going right down the drain. So, how do we actually conquer this enemy? Well, it takes some serious thermodynamic and mechanical precision. To physically force those microscopic carbon particles apart so they mix evenly, you need the perfect processing temperature for fluidity. You need the exact screw configuration inside your extrusion machinery. You need adequate shear force to just physically rip those clumps of carbon apart. And of course, you need precise carrier selection. When it all comes together, it's basically a highly tuned mechanical symphony. Let's get practical with Section 5, Troubleshooting Common Defects. Now we're going to connect that formulation chemistry directly to the visual defects you might actually see on the factory floor. So say your plastic looks grayish-black. Your root cause is likely a low carbon loading or maybe just a really poor carbon grade. The fix? Pretty simple. Upgrade your carbon or bump up the percentage. But what if it looks brownish? Well, that's the polymer itself influencing the light refraction. You solve that by switching to a carbon that has a strong bluish undertone. Seeing black specks? Those are agglomerates. Basically, your dispersion failed, so you need to step up your mixing shear force. And finally, if your black is just looking dull, you've probably overheated the polymer. Time to go optimize your machinery's temperature settings. And that brings us to our final stop, Section 6, the golden rule. Look, a professional R&D engineer doesn't just guess out there. They follow a very strict hierarchy of needs. Step 1, they define the target jetness that the customer actually requires. Step 2, they engineer the formula to ensure absolutely perfect dispersion. Step 3, they guarantee the necessary UV stability based on what the application is. Step 4, they optimize the processing parameters for the factory machinery. And finally, Step 5, only after all those quality metrics are hit do they work to control costs. Notice something missing? Yeah, throwing more cheap carbon into the mix is definitely not a step here. Bad engineering simply cannot be fixed by just dumping in more raw material. All of this really boils down to one defining industry philosophy. Seriously, write this down. The best master batch is not the one with the most carbon, but the one where the carbon is best dispersed. That right there is the absolute defining truth of polymer coloration. And just like that, we've reached the end of our deep dive. We've shattered that simple mixing myth, and we've mastered the real science of carbon selection, undertones, and the absolute non-negotiable need for perfect dispersion. But before you go, I want to leave you with this final thought. The next time you see a faded, streaky black plastic product out in the wild, ask yourself, was it a failure of the pigment or was it a failure of the process? Something to think about. Now, are you ready to take your skills even further? In Day 20, we're pivoting into color pigment strategies, advanced cost reduction techniques, and commercial R&D workflows. It's going to be a good one. You won't want to miss it. Stay curious, and I'll see you in the next explainer.
So that's a complete overview of Black Masterbatch formulation, from selecting the right carbon black grade to achieving maximum jetness, excellent dispersion, and solving common production issues. Remember, making a high quality black masterbatch is not just about adding carbon black. It's about understanding practical size, particle size, structure, loading level, carrier region, compatibility, processing condition, and dispersion techniques. Even a small mistake can affect color, strength, gloss, UV, performance, and final product quality. If you are working quality production, R&D, or color development, mastering these fundamentals can help you reduce rejection, improve consistency, and develop premium black formulation with confidence. In the coming video, we will dive even deeper into advanced black masterbatch development, carbon black comparison, formulation optimization, cost reduction strategy, and real industrial troubleshooting case that professionals face every day. If you found this video valuable, make sure to hit the like button, share it with your colleagues and friends in the plastic industry, and subscribe to the channel so you don't miss any upcoming technical content. Also, let me know in the comment what is the biggest challenge you face while working with Black Masterbatch. Poor dispersion, low jetness, high loading requirement or processing issue. Your question may be featured in our future video. Thank you for watching. Keep learning, keep innovating and keep growing in the world of plastic and polymer technology. See you in the next video. Thank you.